Here's trigonometry. Here is an up-down line. Up is bigger numbers, down is smaller numbers, below 0 is negative numbers. Here's the same line, but left-right instead of up and down. Right is bigger, left is smaller. The center of both lines is 0. Here's a circle with a radius of 1. Here's a dot on the circle. The dot can be anywhere on the circle, like here, or right there. In this position, the dot is 40 degrees from the right side of the left-right line. What, you don't believe me? Here's proof. Okay, let's just put that fact up there. This is where things get interesting. Here's a fake line. Let's use this fake line to measure how far to the right the dot is. My excessively accurate measuring stick says the dot is approximately this far right. Let's just put that up there, and let's just measure how far up the dot is. We can save that one too. Okay, time for some audience participation. Get out your calculator, press the sin button on that calculator, then type 40 degrees, then press enter, and then press the cos button on your calculator. Again, type in 40 degrees and press enter. Oh my! Cos 40 was essentially the same as dot rightness, and sine 40 was essentially the same as dot upness. We've discovered something here. We now know that the sin button on your calculator finds you the upness of the dot on the circle, and the cos button finds you the rightness of the dot on the circle. Let's just give this a quick road test. Here's a dot from earlier where we've measured its rightness. As you can see, the dot is actually on the left, so its rightness is negative. Now, grab your calculator again and press the arc cos button and then type in that number, and voila! You have an angle. And if we measure the angle to the dot like we did before, we can see that these angles match. Not only have we tested our theory, but we've now figured out what the arc buttons do on our calculator. The arc cos finds the angle of the dot using the rightness, and so, hey presto, the arc sine button finds the upness of the dot on the circle. Or, if your calculator is stupid, it will give you a negative angle that is down and around to the dot, rather than a positive angle that is up and around to the dot. But what if we don't have a circle of radius 1? Well, that's easy. If we're finding the angle from the rightness or the upness, we just have to divide our rightness or upness by the radius of the circle, like here, where we have a circle of radius 2, and then we divide the upness by the radius and do the steps from before, which gets us the angle of the dot. Oh yay. And if we want to get the upness or the rightness from the dot on the circle, all we have to do is multiply by the radius. Quelle surprise. You know, those fake lines down the bottom there really do look like a right-angled triangle. Let's go back to our original circle. And now, I hate to do this, but you're just going to have to take this one as fact, that if you square the upness, and then you square the rightness, and you add those two things together, you get the radius squared. If you already know Pythagoras' theorem, you should be able to see it from the triangle there down the bottom. See? There's 90 degrees. We can see our upness marked there on the up-down line. So all we'd need to know to find the radius, which we know is 1, is the rightness of that fake left-right line down the bottom. Or, in other words, the dot's rightness. So we can plug in all the numbers and work out that our radius is 1, but we know from before that dot rightness and dot upness are just the sin and cos of the angle of the dot. So we can just use the sin and cos of the angle of the dot. And moving back through our previous examples, we can see that this rule holds no matter where we put the dot on the circle, because the diagonal is always our hypotenuse, and our rightness and upness are always the other sides of the triangle. And so we have discovered another rule. The sin of the dot angle squared plus the cos of the dot angle squared always equals 1. That is always true, no matter what. You can try that on your calculator. And now you know everything about trigonometry. And if someone asks you about tan, you can tell them they're stupid, because tan is only just sin of the dot angle divided by cos of the dot angle, or upness divided by rightness. And if they can't divide by two numbers, well... Anyway, that's all of trigonometry. Now go outside.